All right. So today we will be talking about some of the PIM mode. And the first one that we will start with is this dense mode. And to be honest, with dense mode, there is not much that need to be discussed. What this dense mode does, it basically flood everywhere. It assume that you need that multicast stream, it will send you, and then you have to specifically tell, no, sir, I don't need it. And then the prune travel all the way. That means dense mode was not efficient at all. We can all agree. Basically, it's if I have a network like this, where here is a source, irrespective of the receiver, it will send the multicast traffic everywhere, and then these guys need to send these prune messages back that we don't need it. Very simple enough. Most of you on the call knows it, and it was a legacy mode. In fact, many of the recent Cisco software doesn't even support it. For example, NXOS dense mode is not supported. iOS XR, especially on the 9K, dense mode is not supported at all. But was there any upside of it? And if I ask you, and then this is a logical question, by the way, layer 2 networks, being a network engineer, we might hate them because it comes with so many problems. But was there any plus point of layer 2 networks? Anybody, just think open and just tell me, take a sip of coffee if you have by your side, and tell me what could be the one advantage that you can think of having a layer 2 network. Anyone? And by the way, this was asked in a very larger forum as well. So I'm just giving that question to you guys as well. What I'm asking is layer 2 network. What is the plus point? What is the advantage of a layer 2 network? Basically, in layer 2 network, you can implement it with very, very minimal to zero configuration. Most of the time, you just plug your endpoints to a switch and they will communicate with each other. So you don't need that much configuration. Whereas layer 3, if you take any protocol, you take anything, that is basically configuration sensitive. You need to configure IP addressing, have to be very careful with that. The two subnets that you configure here should be in the same subnet. You need to configure routing protocol, all those things, and proper policies in case you have that. Layer 3 is very configuration intensive versus layer 2 was very, very minimal on that side. Same way, PIM dense mode versus sparse mode. Dense mode, you don't need any config as such. It just simply work. I had seen it in the past. It's not efficient, I agree. But when we used to run PIM dense mode, at least in a very controlled environment, my team was sleeping very peacefully because it just worked. Even a L1 engineer, you give this configure, multicast will work. Otherwise, multicast, we will talk about troubleshooting as well in our advanced sessions. But troubleshooting multicast is something that can get very complicated, by the way, for the lack of better word. So that was the advantage for the dense mode as well as layer 2, but both of them, the problem is common. They don't scale well. They are not efficient. There is a lot of inefficiency that is involved. Let's just go to the sparse mode. And here, I would request you guys, each one of you, to join this discussion. We will have a simple topology. let's say a very simple set of devices that we have. One side is the receiver. Other side we have a source. Between the receiver and the router, we have already talked about it, that the language that they speak is IGMP. But today we will take a deeper look, at least on the conceptual this thing, and then we will validate each of these things on the CLI also. Maybe I will not be able to validate all of them for you, but we will see some of these things in action as well in the lab. Currently, from the lab perspective, I'm trying to build a topology for you guys which fit most of the scenarios. So we don't juggle up between the topologies. One topology, just go with it. So that's where we are. We will see whatever we are talking today in the lab for sure. So when IGMP join come from this receiver and hit your router, let's say this is my LHR. What this LHR will do? Immediately you should see a star comma G entry here on this device. At that star comma G will be converted into a PIM join. And will travel hop by hop. What does that mean? Let's say this is my RP. In this RP and this LHR, you should see star comma G on every node. And one more thing here. This PIM join phase, let's say this is the interface where I am receiving a PIM join. What will happen is when you will check your OIL, outgoing interface list, this interface should be there in the OIL. And this is what I'm saying from the experience. What we are talking is a normal logical flow of a multicast. Vendors, and when it comes to implementation, things work differently, as we have talked in our very first session also, or it was second session. But what you should see here is that this PIM join is traveling hop by hop and it stop at here, right at your RP. That means on this device, you will not see any star comma G, and that's absolutely fine because this is not coming in that path. And for this also, what you need is this PIM protocol. And in this I stand for independent. What does that mean? I can have any routing protocol, unicast routing protocol for my multicast to function. In fact, we were debating about multicast being a routed protocol or multicast is a way of communication right at the start of this session. But multicast, you can treat it like an overlay which ride on top of your unicast routing. If unicast routing is messed up, multicast will not work. So it can be that first overlay type which is there for your multicast. Unicast is working, that should be fine. That should be your first goal. If that is not working, multicast will not work. So this PIM join is something that also with the star comma G, you should be looking for in the sparse mode from the receiver side. This star comma G entries will stop here at RP itself. Now there is a source that come into picture. At this source, will start sending, let's say the IP of the source is 1.1.1.1, and it sends the traffic to, this will be multicast address 225.1.1.1. And this traffic with this as source and this as receiver or destination IP address basically hit this gateway router. What this gateway router will do? Listen to me very carefully here. This is completely different from this side of the house. The way receiver join and propagate the information around that receiver in the multicast is completely different from a source point of view. And I will tell you why. But before that, let's just understand why that is the case. When the source here receive this multicast, what it will do? It will encapsulate that. I will show you in what it will get encapsulated also, but it will encapsulate that and will send that towards the RP. First of all, few things to be noted here. This encapsulation that happens is a unicast. And this is a register message. What basically it want to register? It want to register this source. To whom? To RP. How? Via encapsulating that message, let's say in a GRE tunnel, and will send that towards the RP. I will take a pause here if there are any questions. When this register message come here, RP will first, what RP will do? RP will decapsulate that message. Will decapsulate and will see what is the content inside, and it will come to know that this is a multicast packet, this packet basically. So it knows that there is this source and it knows that there is this group that this source is sending the multicast. Because we have the receivers already, that PIM join that traveled hop by hop to the RP, already it is there. RP will say that, okay, there is some interested receivers for this group. Let me initiate a PIM join towards source. And like any PIM join, this PIM join will also travel hop by hop towards that first hop router, FHR. So this is where for the next 10 minutes, please be super attentive. If you give me your 10 minutes, I will make sure that this thing is clear. And what we are talking, by the way, now is about an ideal world where you go and you are looking for somebody, and in the first instance itself, you are finding him. But what if he is hiding under the hood? You struggle to find him. What happens in those cases? That is what we will be talking about. We will see why it is happening in this way. So next 10 to 15 minutes. So this PIM join will travel hop by hop, and now this FHR will receive this entry that, okay, somebody want to join a multicast group. I already have an entry, so let me send the multicast directly. So now basically your multicast traffic will travel. So the green line that you see will be your multicast traffic that will carry this will be carried along this green path. But here there is one problem that we see already. One is, and then I will come to the basic problem, but one is this encapsulation. This FHR is still sending the packet encapsulated, and your live multicast is also flowing. So RP is now getting two copies. This is inefficient. And on top of that, this multicast traffic going on this encapsulation, that means RP has to decapsulate it really fast and send that traffic. Again, not at all inefficient and not at all efficient. What it will do? It will send a register stop message. That please don't send me this encapsulated multicast traffic anymore. So this will stop, but this traffic will continue to flow.
So when you say RP receives two copies, could you elaborate like what what two copies? So I understand one is encapsulated.
And
What's the
another
other
one
one?
is the real multicast traffic, because your
Uh,
PIM join, which I was saying, this PIM join, right, that was traveling hop by hop. So when that PIM join reaches this FHR, this FHR will start sending the live traffic or that stream native multicast also. And that who requested that multicast? RP.
yes,
Who
yes.
sent that PIM join? It is the RP who had sent that. So where the multicast traffic will go? Multicast traffic will go in this direction. Your PIM join come, multicast will go. Does that make sense? It is as
So
simple as that, that if I am receiving a PIM join, I will send the multicast traffic. The only condition that I have is I should have that matching multicast traffic. What does that mean? You are sending me a PIM join for group 225.1.1.1. If I have the multicast traffic for the same, I will be happily sending it to you. But if I don't have, I will keep an entry for it, and I will be thinking that, okay, if I am not having it, but there is this government registrar, there is this government office which maintain every entry, that he might be having it. So let me just pass on this PIM join message to this RP. So RP will have star comma G, but RP is helpless here because there is no source. RP can only keep that star comma G entry, and RP will say, I don't know this person, but if I come to know, I will definitely let you know. I mean, I will definitely forward that stream. Now what happened? Suddenly a person come with this group itself, hit this router, and this router says, let me encapsulate this completely, that multicast packet itself, encapsulate it, and where to send? To that government registrar, to that RP only. Now RP will open it and see, oh, this is the traffic for 225.1.1.1. Somebody is already asking about it. So how can I get it so that I can pass on? So for that, in that registration message itself, RP will see who is the source. 1.1.1 is the source. So it will again, how I can ask the multicast? PIM join is the only way. So RP will say, look, Mr. 1.1.1, I am sending this PIM join to you. And once you receive this PIM join, send me the multicast traffic. So that PIM join will travel hop by hop from this guy to this guy. And when FHR receive it, FHR will see PIM join. That is basically a indirect way of saying, send me the multicast traffic, send me the multicast traffic. For what? Whatever the group in that PIM join. I will show you the structure of PIM join, don't worry about it. But in that PIM join, when you open it up, somewhere you will see, I need the multicast traffic for this group. FHR will say, oh, guess what? I'm sending for this group. So, which path you have come, PIM join? He had come on this path. And what I said when I was starting this, your PIM join, the interface on which you receive the PIM join, you will put that in this OIL, outgoing interface list. That means I received the PIM join on this interface for FHR. I will put this interface in OIL. So when the multicast traffic comes, it will go on this interface because this is in OIL. Traffic, multicast traffic reaches here. Now this guy, now multicast will ask this guy, what is your outgoing interface list? On what interface I have received PIM join here? On this interface because this is my RP. So multicast traffic will go in this way. Now it will come to RP. And RP, it will say, okay, now I am coming. Where you want me to send? He will say, I have received the PIM join on this interface for the same group. So let me send here. Then let me send here. But at the same time, this register message was also there, which was sending. Source was completely sending it. RP will say, I am getting the native multicast now. I don't need this. So it will send this register stop. I will again take a pause. Any questions?
Uh,
And
so,
I, yeah,
so,
go ahead.
Sorry, so it means all the multicast traffic intended for the receiver is compulsory to transverse through the RP. It cannot go directly.
I will come to that point, sir. But
Okay,
yes, for now,
okay.
you assume that yes, that is the case. And this is very important. I don't mind repeating it. My only sole aim is that you guys get this. And then, by the way, we will introduce some twist into it. I'm just waiting for you to get this basic straight. Then we will come at certain twist. Some of you were there in the BGP sessions as well. What I have told you in the BGP, your route will go, traffic will come. They work inversely, right? In the opposite direction. Same way, your PIM join will come, multicast traffic will go. PIM join travel in this direction. I can take another color here. And multicast traffic, as you can see, follow exactly opposite. I will repeat that one more time. Receiver come online, it will start this IGMP join message that come to your last stop router. IGMP join will get converted to PIM join. And at this point, this PIM join, what they know we need the multicast traffic for this group, but we don't know the source. We are fine with any source, but dear network, please help us to get this multicast traffic. The LHR, the last stop router will say, I don't have a multicast for this, but I know this government registrar, this government authority, which told me that if you don't know something, just send it to me. I will figure it out for you. So let me send this PIM join to this guy, but PIM join travel hop by hop. Whenever you receive a PIM join, that interface, basically this one, you put in the OIL, outgoing interface list. Once you come on RP will say, oh, I don't know. When source come online, your RP know, and it just patch those two. As simple as that. Anybody, any questions?
What is the case like if the RP sends but the source doesn't exist?
Okay, that's a good question. What if the case where a source doesn't even exist? Then you will have only this entry star comma G till your RP. And RP will say that as and when there is a source which comes online, I can help you out, but till then, just stay like that.
Okay. Means it will try for minimal interval or uh,
No, it will see these PIM joins, they keep on refreshing themselves. Even
okay.
this IGMP message, right? It's that message that you see here in between your last hop router and the receiver. It's not like I just send one IGMP and my job is done. It's a chatty protocol. They keep on refreshing, like your, if I want to give you an example, your OSPF, they keep on exchanging the hellos, right? Same ways, there are certain timers where these states get refreshed. Like, do you still need it? Do you still need it? Something like that. Okay. But
Yes.
yeah, good question. Yeah, I see
So,
one raise of hand.
yeah, Sunil, just one question.
Yes.
In this case, what will happen that if the any receiver configured properly with RP information and whatever is the related information, they will start sending the IGMP join. So how we can prevent that?
No, no, I didn't get that.
No, my question is that how we can prevent that any receiver that does not start sending the IGMP join message. Because in this case, what will happen that you see there is no control. If any receiver comes into the network with proper configuration, they will start sending the IGMP join. So is there any mechanism that we can prevent that?
Yes. So basically, you can configure access lists. You can
Hmm.
configure access list here at RP level also,
Yeah.
and tell this guy that you are only supposed to accept the request for this particular group range, let's say. For
Okay.
example, if
Okay.
I'm configuring an RP for just 225.0.0.0, if a
Hmm.
request come for 2 to 6, this RP will not entertain that.
So we can configure in the RP, not on the first hop router.
Okay. So RP, okay, we need to talk about it, but since we are getting there, this is good part, by the way, how
Mm-hmm.
this guy will know the RP, how LHR will know the RP. There are three ways that exist.
Mm-hmm.
One, you configure statically.
Yeah.
Other one, you configure via auto RP.
Yeah.
Third one, you configure via PSR. We will
Yes.
talk about all these things. But in these three methods, you also tell this LHR, this last hop router, that this is the RP, but what group this RP is serving.
Mhm.
So
Okay.
your request, which is not, let's say, legitimate, that will get killed there itself.
Okay. Got it. Good.
However, there is one catch with that we will be talking maybe on Wednesday now, because today it's a bit heavy.
So it means we can have multiple RPs in the network, right?
Yes, you can have multiple RPs in the network.
Okay. And if I have a question like how how to decide like which router we should go for RP. It's
Configuration.
all no, not configuration wise, like how to decide which router we should select as a RP. It should be always closest to the source or like how?
Okay, that's a design question. See, we will come to this.
Okay,
But
that's it.
before that, just think here what this RP is doing, what this government entity, let's say, which we are comparing it with, is doing. It is telling the LHR who is the FHR. Once I know that who is the FHR, do I really need RP? do, or let's say if you want to inquire about me, you go to this government office and say where Sunil reside, and they tell you my address. You come to me, and let's say we do whatever you came for. Tomorrow you want to come for the same thing. Will you again go to this government office, sir? Tell me where Sunil is. Now you know my address, right? You can come to me directly. So that's what the hint I want to give you on the role of RP. Most of you have asked, what if like this source is not there? What will happen? What if the receivers are not there? There is only a source which is sending the multicast traffic. What if receivers are not there? What will happen? In that case, I think I'm running out of colors here, but let's just illustrate this here only. When this part doesn't exist, can source still send the traffic? First of all, yes or no? Just answer it in yes or no. If there are no receiver, can a source send the traffic at all? Yes or no? Simply.
So until unless we get a request from RP, I don't think so. Source
No.
will send anything.
Okay.
No.
Source will send anyway, but it will not be forwarded to any receivers.
Yeah. So this is what I have told you. This side, you need protocols, IGMP, to register basically your interest with the RP. Let's say currently we are talking about this RP based multicast, but source, it doesn't need any protocol. Simply a source here, let's say a server or whatever, will simply start sending the multicast traffic irrespective of the receivers are there or not. Source doesn't even care. But then what will happen? The traffic will come to FHR. FHR will see, FHR will see here that I need to register this basically. So it will encapsulate that and send that to the RP. RP will decapsulate the packet and RP will see that, oh, this is a multicast traffic and this multicast is destined for 225.1.1.1. Do I have a receiver for it? How it will check? Does it have a receiver? It will check whether there is any star comma G entry exist on RP or not. If there are no entries, it will send a register stop message directly here. But in this case, there is one difference. It will not initiate this PIM join. It will only send this register stop here to the FHR that, look, I got to know that, okay, you want to send the traffic for 225.1.1.1, but nobody is there. Sorry. Let me send you a stop message. It will send the stop to FHR. Does that make sense? And let's say, let's just go a little further here. It sends the register stop message. And then immediately after sending the register stop message, let's say, one receiver wake up, it sent that IGMP join, which is converted to PIM join and travel to RP. Now what will happen? So basically, like any protocols, right? That protocol that keep on trying that, are you alive? Are you alive? Are you alive? And then you get, yes, I'm alive. Same way, this FHR, after getting the register stop message, and if it does not get that PIM join, it will basically suppress that for some time. There is a random timer, and once that timer expires, it will again initiate a register message. Okay, and then it will send that towards your RP again. So this time RP will say, yes, honey, I have a receiver now, so let me send you a PIM join now. So your PIM join will travel. And PIM join, how does it travel? It travel hop by hop. This is something which is very important to understand.
And Sunil, we have only two mode, or we have any other mode?
Yeah, we have a third mode as well. I wanted to talk about that. If you understand this part and the session that we will be having on Wednesday, today none of you have asked. And it's okay. Like, I'm not complaining. It's okay, but why we need this register message? Why can't hear the multicast traffic flow directly from your source side as well, like the way these PIM joins were coming from the receiver side? Why we need this encapsulation, fancy encapsulations and all that, right? So there is a lot under this also, but this is the fundamental. If you understand this, understanding multicast will be a piece of cake. So with that, I think it was heavy today. So let's just stop here. I'm still there for any questions, but some more topics like new things we will talk on Wednesday now.